Our next lesson is called the slope of a non-vertical line. So for this opening exercise, I want you to complete this on your own. The questions are all set up the same. So questions 1, 2, and 3, you're going to see 3 different graphs. They are labeled A for line A and B for line B. All of the questions say that the graph below shows lines A and B, and to answer the following questions. I want to know which line is steeper, and then I want to know why do you think this? Okay, so at this time, please pause the video, then resume the video to go over the answers once you've completed these questions on your own. All right, so we're going to learn about the slope of a non-vertical line today. So I want to introduce it to you by this opening exercise because it's really about how steep something is. And I know how steep something is, or steepness, is something that you're familiar with. So in the first question, when you look at the graph, to me, line B looks steeper. And that's because it's closer to being like a vertical line than A is. If I was thinking about having to climb these like a hill, it would definitely be harder for me to climb B than A because it definitely looks steeper to me. Then in number 2, these appeared to be the same steepness to me. They looked pretty much the same. So I said line A and B looked angled in the same way. And then in number 3, this one may be a little bit more difficult because they're not both going the same direction. But looking at it from maybe a downhill perspective, if I was going down line A or down line B, I definitely think line B is steeper because, again, it's closer to being vertical than line A is. So we know in math that we can't just say we think this is the answer. We have to have mathematical reasoning or proof or work that shows it. So today, we're going to talk about finding the slope of a line, and slope measures the steepness of the line. We can find the slope of the line using the ratio rise over run. A rise is a change in the y values, and a run is a change in the x values. So we're going to do 4 examples together to look at different scenarios and talk about how we can assign a number for the slope so that we can definitely decide which line is steeper. So in the first example, and in all of these examples, since we're doing them together, there are no points plotted on the line. So I want to make sure you plot the exact points that I do. So the first point I'm going to plot is here at 0, -1. Notice that I'm picking a nice point that crosses at a grid line. And then the next point I see if I look to the right is this one at 1, 1. Now, slope is rise over run. So we're going to come down here. We use the letter M for slope. And I'm going to say, starting at this point right here, am I going to go up or down to get to the next point? We're going to go up, specifically 2 spots. So I'm going up 2. And then I'm going to the right 1 spot, right 1. So then we're going to think about this up. Would that be positive or negative? Well, up is positive, so that's a positive 2. Right 1, would that be positive or negative? Since it's to the right, it would be positive. So my slope is 2 over 1 or 2. So this particular one happens to also be an example of what we would call a unit rate from your previous years. There are times when your slope is going to have a denominator of 1. All right, let's look at example B. We are going to plot 2 points on the line. So we're going to plot 0, -1, and 3, 1. Points that are next to each other on the line, easily to count because they're landing nicely in the grid marks. And we're going to go down here and put M equals, and we're going to start with the point on the left. And do I have to go up or down to get to the next point? I have to go up. How many blocks? 2. So up 2. And I have to go to the right. How many blocks? 3. So right 3. So up 2 would be a positive 2. Right 3 would be a positive 3, so my slope is 2/3. Now, sometimes the scale's not going to be going by ones. So we want to pay attention to that. So I'm going to highlight, watch out for scale. We are still going to follow the same process. I'm going to plot the point 0, -30. And then I'm going to plot this point, which is actually at 100, -20. And we are going to find this slope. So I'd have to go up 1 block, but my 1 block is worth 10. So that would be up 10. I then have to go to the right 2 blocks. When I look at what the 2 blocks are worth, each block is 50, so that would be 100. Right? 100. Okay? So if I go up 10 and right 100, that means I have a slope of 10 over 100, positive 10 and positive 100. Now I can write it like that. But if you recognize it, and we'll talk more about this in our next lesson, we can simplify this. 10 over 100 is the same as 1/10. And again, we will talk more about that in the next lesson. Now, I wanted to do this last one, part D. Because for the first time, we're not slanted in a positive way. We have a different type of line here. So let's look and see how it affects the slope. So the first point I'm going to pick is 2, 5. And then we're going to pick 4, 2. Going from left to right, I'd have to go down 3. So M equals down 3. And then right 2. Down 3, everything else has been up. When it was up, it was positive. So down 3 would be a -3. Right 2 would be a positive 2. So the way we write this typically is we put the negative even with the fraction line for M equals -3/2. So this one had a negative answer for slope. So now that we know that we can actually assign a number to how steep the line is by finding what's called the slope, which is rise over run, we're going to revisit our exercises from the opening activity and actually prove why mathematically one is steeper than the other. So we are going to find the slope of line A and line B, okay? We'll start with line A. Points are already plotted for me, so I'm going to pick these two. I'm going to go up 2 to the right 3. So M equals up 2, right 3. Which means my slope is up 2 is positive, right 3 is positive. My slope is 2/3. If we do the same thing for line B, I go up 3 to the right 1. So M equals up 3, right 1. So that means M equals up 3 is positive 3, right 1 is positive 1. So 3 over 1 or just regular old 3. So now, which line is steeper? We originally thought it was B, and now when I look at the mathematical proof, I see 2/3 as a slope for A, and I see 3 for a slope of B. So I have proven that slope B is actually steeper because the slope is bigger than 2/3. So we'll say line B, because a slope of 3 is greater than a slope of 2/3. So you might even see it written like this: 3 is greater than 2/3. So since it had the higher number for slope, it's the steeper line. All right, I'd like you to pause the video and try just number 2 on your own. Okay, just number 2. Pause the video, try 2 on your own, and then I want you to come back to go over the answers with me. Right, now that you had a chance to try number 2, let's look at the answers. The slope for line A, you went up 3 to the right 4. So that's a slope of 3/4. And then for line B, you went up 3 to the right 4. That's a slope of 3/4. So we thought they were the same steepness, and now we have the mathematical proof. They have the same steepness because they both have a slope of 3/4. 3/4 is equal to 3/4. Their slopes are the same. So they have the same exact steepness. We'll finish by completing 3 together because this one poses a little bit of a challenge. Okay, so we're going to put a little star next to it. And we're going to start the same way we did for the other ones. We're going to find the slope of each of these lines. So the slope for line A, we're going to go down 1 to the right 3. So M equals down 1, right 3. So that means my slope is down 1 is -1 over +3 for a slope of -1/3. When I do that for line B, I'm going down 3 to the right 1. So M equals down 3, right 1. That means M is, down 3 is -3 over 1, which is the same as -3. Now, if we use the same logic we did for question 1 and 2, -3 is less than -1/3, but we said line B was definitely steeper. So I want to make a note of that. Make a little star. Line B is steeper, but -3 is less than -1/3, not greater. So this is why I wanted to complete this one together. For any negative slopes, you must compare the absolute values. So absolute values you did in a prior grade, and I'm not sure how much you remember about it. An absolute value measures the distance that number is away from 0. So for example, the absolute value of 2 is 2. The absolute value of -4, how far is -4 away from 0? 4, right? So we want to take the absolute value of -3, which is 3. That's the distance -3 is away from 0. We want to take the absolute value of -1/3. So the distance of -1/3 is away from 0 is 1/3. And when you look at the absolute values, which means you look at the positive values, 3 is actually greater than 1/3. And that is how it proves that that line is steeper. So for negative slopes, it's a little bit trickier, but the main idea here is that we can assign the steepness of a line by finding the slope of a line. To find the slope of a line, you use rise over run. And we're really going to be building on this concept over the next few lessons. So that concludes our lesson on the slope of a non-vertical line.